Hi students, in this video I am going to discuss geometrical isomerism. Next part, isomerism topic, structural isomerism successfully we have completed. So this is the topic geometrical isomerism I am going to teach. First look into the definition. Compounds are having same molecular formula but differ in their spatial arrangement of atoms or groups. In space, arrangement is different. Molecular formula is same. Okay, to understand more better, I am giving one simple example. Look into this. Suppose C double bond C. Compounds are having same molecular formula but differ in their spatial arrangement of atoms or groups. Okay, this is students, it arises due to restricted rotation of C double bond C. That point also better to write first. This is definition point 1. Next point, point 2. It arises due to restricted rotation of C double bond C. So whenever double bonds is there, so it is not possible to rotate freely. Restricted rotation. Because of restricted rotation, we are learning geometrical isomerism for double bonded carbons. Okay, and with double bonded C double bond N, C double bond C, like that I am showing all the examples in today's video. Now first one, to understand the definition I am giving simplest example. Look into this. C double bond C. I have written here two elements. This is A, this is A, this is B, this is B. See, similar groups on same side. Better to write. Third point. Similar groups on same side. Similar groups on same side called cis isomer. See students here, similar groups A, B, B. Same side, no? Same side means we call it as cis. And point 4. What is point 4? The same molecular formula. C double bond C I have taken. I am taking A, 2A, but I am writing opposite. I am not removing anything, just arrangement is different. Here same side, here opposite side. What is this? We call it as trans. So can you tell what is this trans definition? Similar groups on opposite side. Write down, that is only. Similar groups on opposite side. Clear? Now to understand more better, I am giving different examples students, all frequently asking in examination points only. Now example 1. 2-butene. It is very easy. 2-butene. 4 carbons, right? Second position double bond. End methyl group. Here hydrogen. Right? So this is active side students. This is active side. This is symmetrical alkene. This is active side. Now around active side carbons, how many atoms and groups are there? First count. C double bond C. See this carbon and this carbon. Okay. This carbon having one hydrogen. Okay. One methyl group. And this carbon having one hydrogen. See, one hydrogen, one methyl group. See, similar groups on same side. What is this? We call it as cis. Trans. Can you write the trans? Same story. C double bond C. Now here, what is this? This carbon having hydrogen. This carbon having methyl group. And this carbon having hydrogen. Hydrogen exactly opposite you can write. I am not removing anything. Just arrangement of atoms and groups changes. That's it. So then what is this? We call it as trans. Cis and trans. What is geometrical isomerism? Explain with an example. Are 2-butene exhibit 2 type of isomers? Write down. So like different questions they are asking. Now I am giving one more. Everyone try this one. What is this? 1,2-dichloroethene. Second example. 1,2-dichloroethene. Ethene means CH double bond CH. 1, this is 2. Second one, first carbon, second carbon. Now you can write cis and trans. Cis and trans you can write. So try this one. Yes, C double bond C. Right? It has hydrogen, chlorine. It has hydrogen, chlorine. Similar groups on same side, then what we call it as cis. Similar groups on opposite side, what we call it as trans. That's it, very easiest topic, right? Trans. Now next one, but-2-ene dioic acid. But-2-ene dioic acid. Example 3. But-2-ene dioic acid. Dioic acid. Okay, I am writing the structure, students, here. COOH. But means how many carbons totally? 4 carbons, right? That to dioic acid, end oic acid, because it is chain terminating functional group, no, always it will come end. Then in between double bond, but-2-ene, CH double bond CH. This is but-2-ene, second position in dioic acid. This one they are asking you to write cis and trans. Is it possible? Yes, you can write along with me. C double bond C, and what is this? It has hydrogen and COOH group. It has hydrogen COOH group. This, what is this? We call it as cis but-2-ene dioic acid. This is cis form. This cis form only generally, common name we call it as malic acid. This is malic acid. Next, trans one. Can you write trans one, students? It has hydrogen. Exactly opposite you can write. The trans one, what is the common name? We call it as fumaric acid. This is one of the important question. That's why I have selected this one. Fumaric acid. Okay. Now, next one. Now, next one, geometrical isomerism in compounds containing C double bond N. So with this, I had given good examples. Everyone hope understood topic. 3 examples I had given, right? With 3 examples, geometrical isomerism, cis and trans you understood, right? Now I am giving here 1 point. Geometrical isomerism, case 2. This is case 2. Case 1 simple. Case 2 little tricky. Geometrical isomerism in compounds containing C double bond and OH. This is what we call it as oximes. Here we have 2 types of oximes. One is aldoximes, and another one is ketoximes. Aldoximes and ketoximes, right? Aldehydes having, aldehyde means one is R group, one is H. One must be hydrogen, that we call it as aldehyde, aldoximes. So ketone means both are R groups or both are AR groups, like that. Okay, now come back to this one. In aldoximes, that means R means alkyl group, like methyl, ethyl, propyl, like this. This is what H, it must be hydrogen. double bond NOH. This is oxide. It has lone pair. Wherever nitrogen is there, definitely it has lone pair, no? Right? So now you can write here cis and trans, but slight changes is there. We are not calling here cis trans. We are calling here syn and anti. Syn is nothing but like cis. Trans is anti is nothing but like trans. Okay? Now, we'll see this point. RH, okay, write down syn, R, C double bond C. It is H double bond. You can take it as your N. Okay, you can take it as N here. And students, lone pair you can write like this. Next, OH group. Simple. H and OH. H and OH on same side. On same side, then what we call it as syn like cis. Okay, similar groups on same side means cis we call, but here not similar groups, no, with respect to hydrogen and OH group we are talking. Clear? Now can you write antiform C double bond N. This is R, no change here, RH, but you can see this is OH. I am flipping this too. Then lone pair down. Then what is this? We call it as H and OH on opposite. H and OH on opposite side. Then we call it as anti. Anti. Okay. Anti-isotoxide, aldoxide, syn aldoxides. That's it. Now next example. I am giving another example. Try to do. Aldoxides completed, no students. Now ketoxides. Ketoxides, aldoxides like this. Hydrogen, no, NOH. Can you try this one? It has lone pair, right? This is general example. This is normal example. And CH3 I have introduced. That's it. So write here. What is this? Syn means it has lone pair, no? H and OH same side. What we call it as syn. And opposite side, what we call it as trans, which is opposite H and OH. That's all. Remaining as it is you can write. This is CH3. This is what we call it as anti. Clear? That's it. Now next one, ketoxides. Ketoxides means both are alkyl groups. Take CH3 double bond and OH. Can you write what is the syn and anti? Syn and anti. Here also same thing. Lone pair. What is this? Hydrogen and OH group on same side. What we call it as syn. Opposite side anti. CH3 double bond and nitrogen has lone pair. They won't give this and all. We have to remember. We have to keep it in mind. That's it. OH group. Okay. Now this is syn. This is syn. Okay. I will change it. Then you can understand more better, students. pH group. Phenyl group. I will introduce phenyl group. Phenyl. This is phenyl. You can write perfect name here. This is synphenyl. Synphenyl methyl ketoxime. Synphenyl. This is phenyl group. Phenyl group is nothing but like this. This is phenyl. Okay. Synphenyl methyl ketoxime. Or else you can write another name. What is this another name? This is what syn. Anti. What is this another one? C double bond C. Anti one you can write. Anti. How to take C double bond N. Lone pair. Okay. Lone pair better to write down. This is CH3 group. This is phenyl group. I am changing this one. Here I am writing OH group. Here I am writing lone pair. Now, with respect to this lone pair, who is here? Who is present here? Phenyl group. This is what we call it as anti. This is exactly anti-methyl. Syn-phenyl. Anti-phenyl. Anti-phenyl methyl ketoxide, or else you can write one more name, syn-methyl anti-phenyl methyl ketoxide, syn-methyl phenyl ketoxide. Did you understand? With respect to OH group I am speaking. With respect to OH group, he is in same side, means syn-methyl. With respect to OH group, phenyl group is opposite side, that is anti I have written. If you want to write here also you can write. What is one more name here? Anti-methyl. This is anti-methyl. Anti-methyl phenyl ketoxide. Okay, final conclusion I am giving here, students. With respect to lone pair we are speaking, with respect to OH group we are speaking, with respect to OH group, syn position phenyl group, same side is nothing but phenyl group, syn-phenyl methyl ketoxide, or else you can write opposite also. Opposite who is there? Methyl group, no? Anti-methyl phenyl ketoxide. Here also same thing. Okay, now next one, azo compounds. Azo compounds is nothing but N double bond N. Case 3. Geometrical isomerism in compounds containing N double bond N. These compounds we call it as azo compounds. Okay, now students, I am giving one example here. C6H5 phenyl group, we can write like this, C6H5 N double bond N, C6H5. This is what we call it as azobenzene. Can you write syn and anti? Okay, we'll try this one. Nitrogen has lone pair, right? Nitrogen has here lone pair, here also lone pair. Okay, now N double bond N, this is active site, right? Now here I am writing lone pair. This nitrogen has lone pair and C6H5 group, and this nitrogen has lone pair, and this is what? C6H5 group. So see, similar groups. What is similar groups? C6H5. This is lone pair, same side. This is easy again. Syn-azo compounds. Syn-azobenzene. Can you write trans? Trans means exactly opposite. Trans. N double bond N. What is this? It has lone pair. Exactly you will write lone pair. That's it. C6H5 group. This is also C6H5 group. That's it, students. What is this? Anti-azobenzene. Okay, with this compounds geometrical isomerism we have completed. Now next one more most important topic, cycloalkanes. Geometrical isomerism, case 4. Geometrical isomerism in cycloalkanes. Cycloalkanes is nothing but like cyclopropane. If you take like this, okay, suppose two substituent they had given Me is nothing but methyl group, Et is nothing but ethyl group, prop is nothing propyl group, like that. Okay, this one they are asking syn and anti, or cis and trans. So can you try this one? So how to write cis form and trans form? See, I am writing. That's it. Okay. Me group. This is Me group. You can write hydrogen, hydrogen. You can write like this, or else some students they will write like this also. One more form. What is this? Here two hydrogens they will write. Here two methyl groups. Always same side. Same side is nothing but similar groups, and same side is nothing but cis. This is what we call it as cis 1,2-dimethyl cyclopropane. Cis 1,2-dimethyl 1,2-dimethyl cyclopropane. Cyclopropane. Can you write trans, students? Can you write trans? Okay. Trans opposite, no? So write your substituents, methyl groups exactly opposite. Hydrogen. Hydrogen. This is what we call it as trans. Or some students they will write in different way also. What is another way? Don't write two. To understand, I am giving all examples, but examination only one you can write. Here, hydrogen, exactly opposite hydrogen, methyl group, methyl group. Finally, what we call it as trans 1,2 dimethyl cyclopropane. Trans 1,2 dimethyl cyclopropane. That's it. Clear? Now, next one. Allenes. Allenes also little confusing, but easy way I am giving points to you. Understood. Easily you can understand. Now write case 5. Allenes. Allenes. I am giving one most important note point, student. Note point 1. Note. Allenes. First of all, what is allenes? Allenes consist of cumulative double bonds. Cumulative, continuous double bonds. Cumulative DBs, double bonds. Okay. Now, look into this. With odd number of double bonds, allenes with odd number of double bonds, odd number of double bonds, and terminal end. Terminal is nothing but end. Terminal carbons bonded two different atoms. Bonded to two different atoms or groups of groups exhibit geometrical isomerism. Group of atoms exhibit GI, that is geometrical isomerism. Okay, I am giving example. First, allenes means how it is. Allenes. First, let me write. Like this. This is exactly allenes. This is allenes. Now, I am giving what is the students? It has A, comma, A and B, and here A, B, then only it exhibit geometrical isomerism. Okay, cumulative double bonds means continuous double bond, that to odd number, then only it can show geometrical isomerism. Next one, I am giving, this is case 1, it exhibit. Case 2, C double bond C, C double bond C. Next, here I have taken AA, this is I have taken AB. Is it exhibit geometrical isomerism? No, no geometrical isomerism. See, odd number is there, odd number of double bonds is there, satisfied, but two different atoms, I said no, two different atoms or groups, here different, but here it is same, that is why it will not exhibit. Okay, you will get questions like this in exam. That's why I am giving. Okay, now third example. Third example. This one. AB. AB. Is it exhibit geometrical isomerism? No geometrical isomerism. Why? Because it has different atoms. Here also different atoms. But it is not odd number. It is not odd number. Even number. Even number is not alkenes. It's no geometry. It will not exhibit geometrical isomerism. No geometrical isomerism. But it can show optical isomerism. Optical isomerism it can show. Next to coming days videos I am explaining optical isomerism. There I will explain alkenes, spiro compounds. Next one biphenyls. That time I will show this one. Okay students. Now next one. Case 1, case 2, case 3. Another points also there. Calculation of number of geometrical isomerism with dissimilar ends, similar ends, odd number. So all the rules next video I am going to upload. EZ nomenclature also I am going to explain students. Thank you. Thanks for watching.